thank you all very much for joining this Wix webinar / virtual meetup / whatever. Learn about web performance. Hopefully, I will be able to convey some useful information to you today. So you've built a website, and it's a good website. It's got good content. The graphics are nice. All the required functionality is there. But unfortunately, it's also slow. Maybe even it's slow because of all the functionality that you put in. And as a result, your bounce rate is high, your conversion is low, your customer is unhappy, your boss is angry. And the question then is, what do you do? How do you fix it? How do you take a slow website and give it the appearance of a quick, fast website? So I've got a solution for you. And the solution is just use a spinner. And that more or less concludes our webinar for today. Thank you all for joining. No, seriously, please don't disconnect yet. Obviously, this is not really a serious solution. In fact, it's a pretty bad one. I guess a spinner is better than nothing at all, but not by much. Because when somebody comes to visit your website, they want to get some meaningful content, something they can do something with. They don't just want to see a spinning circle. And unfortunately, it's become quite common in the web today that whenever we go to websites or we try to access additional functionality, instead of what we want to do, we get the spinner instead. So the actual topic of the conversation for today will be not how to mask slow websites using spinners, but rather how to get to a point where we don't hopefully need spinners anymore. So allow me to introduce myself. My name is Dan Shappir, and I'm coming from my home in Tel Aviv, Israel, where despite this being a wonderful day, I'm kind of locked indoors because we're under lockdown, I assume like many of you. And by the way, wherever you're joining us from, I hope all of you are healthy and well and safe and doing fine, and certainly stay safe. I work at Wix. I've been with Wix for the past 5.5 years, coming on 6. And my role at Wix is performance tech lead. That means that I have my everyday job is to make the websites built and hosted on the Wix platform load and execute as quickly as possible. And that's quite a significant task because we have approximately 100 million websites loaded built and hosted on our website, on our web platform. So whenever I make any progress, and not just me, us and the entire company, manage to improve the performance, it actually goes quite a long way. But it's important for me to emphasize that the talk today is not about Wix or Wix websites. Obviously, a lot of the techniques and technologies that I'll be describing are those that we've learned and used while improving performance of our own websites and web services. But all of them are relevant regardless of whatever technology you happen to be using. It could be a static website, it could be a dynamic website, it could be hosted on Wix or on WordPress, it could be one that you build completely by yourself using just plain vanilla HTML, or maybe using React or Vue or whatever other platform you like. All of these guidelines and rules that I'm going to give are going to be relevant in almost any use case that you can think of. Okay then, so I've been talking about slow websites, and I have to tell you that there's one really common thing that I see that I feel or experience whenever I see a slow loading website. They all make me angry. They make me angry, obviously, as a visitor. I mean, who likes to go to a website and instead of getting the content that I came for, just see a blank screen or that spinner that we mentioned before? Obviously, not me and not you. But it also makes me angry from a technological perspective, because looking at many of those sites, my conclusion is that there's really no good reason for the sites to be that slow. That when I look at their content, when I look at their functionality, I think that these sites should have been able to load much, much faster than they actually do. Which brings us to the question of, if in that case, why are they so slow? Why is it taking them so long to actually load? Before I get into that, I also want to mention that it's not only me who gets upset by a slow loading website. In fact, it turns out that it's true for most people. This is a graph created by a company called Pingdom. It's a company that deals significantly and specifically in web performance, and they've collected a lot of data around the implications of slow loading websites. And I apologize for the small numbers. Hopefully you're able to see the slide clearly. The important line is actually the blue one, which correlates between website loading speed, how long it takes for a website to load in seconds, and the bounce rate. For those of you who don't know, bounce rate is the rate of visitors to your site who arrive at the landing page, but then leave without going to any other page in your site. In other words, they're not really interacting with your site. So for example, let's say you've got an e-commerce site, they've arrived, they've looked at the products maybe that you've got listed on the landing page, but they didn't purchase any product. They didn't even look at it in detail. And they probably also didn't go into pages that list all the other products and services that you happen to have. Now, in some cases, in some websites, obviously just the landing page is enough. Let's say it's a blog post and you just want people to read the blog post itself. But in most cases, you definitely want people to go through through the pages on your site. Even with a blog post, you probably want those visitors to read additional blog posts on your site. And like I said, certainly with sites like e-commerce sites, you definitely want them to navigate around. If they just bounce, it's kind of like people arriving at a physical store, walking into the front door, stopping at the door, looking around, and then turning around and leaving without talking with anybody, without looking in detail at anything. So basically, it's people who you've managed to get to the door, which, as we know, it's not easy. It's often pretty expensive, but then you just lost them. And with web pages, it turns out that if your web pages are slow to load, the probability of a high bounce rate goes up really quickly. So if you look at this graph, we can see that once it takes a site 4 seconds to load, then the bounce rate is over 20%. That means that more than 1 out of 5 people who visit your site will just leave because of that slow loading website. And it gets worse. I mean, once we get to around 5 seconds, it's already close to 40%, and beyond 7 seconds, it's above 50%. Now, obviously, performance is not the only cause for bounce rate, but as we can see, there's significant correlation between the performance and the bounce rate for a website. Okay, so it's fairly clear to us why we want a fast-loading website. I mean, otherwise we probably wouldn't be here in this webinar. But if that's the case, what can we do about it? What are the common reasons? Well, reason number one that I typically see that is causing websites to be slow is lack of planning. What I mean by that is that when a product or the customer or you sat down and try to figure out what are the requirements for the website, nobody thought to mention performance. Now, it used to be that would be kind of a common occurrence because people found it very difficult to specify performance requirements. People weren't sure what should be expected. I mean, what is a slow website? What is a fast website? But these days, there's really no excuse for that. Thanks to companies like Google and others, we now have clear numbers and indicators about performance. So for example, for time to visible, which is how long it takes a web page to display visible content from when the user started the navigation process, Well, it turns out that if you want your website to be considered fast, then the time to visible should be between under a second or a second and a quarter, certainly less than a second and a half. If it takes longer than that, well, your website isn't fast. And if it takes longer than 2.5 or 3 seconds for the page to become visible, then your website is definitely slow. And you're going to be suffering for that, like I said before, with high bounce rate. And lack of planning means that you're probably not going to be allocating resources for that. So it means that you haven't planned for it, you haven't specified what performance you want to achieve, you haven't allocated resources in order to achieve it, and you certainly won't be testing for it once you've finished building your website. Given all of that, it's not really surprising that the website you'll end up with will likely be slow, because when we don't plan for something, that thing usually doesn't happen of its own. We need to put in effort for something to actually happen, and web performance is no different. The second thing that I see as a big cause for slow loading websites is that people tend to push way too much content onto their sites in general. Their landing page in particular, and above the fold, the most so. And I'll get to in a second to the meaning of the term above the fold. So, you build a website for an organization or a company, everybody in that organization wants to have the stuff that's relevant for them on the homepage or on the landing page. Let's say you're selling multiple services and products. Well, the salesperson of each and every product wants their product to be on the homepage. Likewise, if you're providing multiple services, it's like reporters in a newspaper wanting every story in the newspaper to be on the front page. Obviously, that can't happen. I mean, we'll end up with such a huge front page that nobody will read the paper. And that's actually what happens with web pages. And especially these days when it's become really common to have these really long pages that you can just scroll through pages and screens and screens and screens of additional content. Now, you might think that, hey, what's so bad about that? I mean, the person can scroll as much as they want. But there are a couple of issues with that. So I've encountered pages, especially on mobile devices, that are, let's say, 20, even 30 screens long. I mean, who really realistically expects a visitor to your landing page who doesn't really know a whole lot about what it is that you're doing or offering to scroll through 30 screens and read all the stuff that you put up there? So you're creating a visual overload on the visitor. But beyond that, it also creates a lot of overload on the browser, on the network. Now, these days, we do have techniques, and I'll get to them later in this presentation, of lazy loading, of loading content only when it's actually needed. But realistically, there are no free lunches. If you load a lot of content, it's going to impact the performance of your page. So my recommendation, make sure that you only put on the landing page or on the home page stuff that's actually relevant, the most relevant stuff for your company. And like I mentioned before, the term above the fold, above that, the fold is that part of the page that's initially visible before you scroll or resize the page. It's what's the first thing that you see before you make any sort of interaction. And that's the most important part, and should definitely just have the content that's really important for the visitors to your site to actually see, and the main content for them. Another common problem that I see in websites is that the people who build the websites just don't know their users. What do I mean by that? For example, do you know where in the world your users are coming from? So I recently spoke with a person who has a fairly popular blog, and he told me that the majority of his visitors, of the visitors to his blog, actually come from India, because he's writing a really technical blog, and it turns out that it's really popular with developers in India. But his server is in the States. So it turns out that even though the majority of his users are connecting from India, they need to connect from their devices, their computers in India, all the way to a server in the States to get the information. So the request goes all the way from India to the States, and then the data has to be downloaded from the United States all the way back down to India. It would have been much better for his users if instead he would have, let's say, set up a virtual server, let's say in Amazon, in a data center that's actually in India. Or alternatively, if he'd set up some sort of a CDN, and we'll get to CDNs in a bit, that would again be in India and would service the information much, much faster. So geographical location of your users is a really significant concern that you need to be aware of when thinking about the performance of your website. Another one might be, for example, the devices that they're using. So let's say you're a technologist and you really dig technology and you got a fairly good salary. So you yourself own the latest and greatest iPhone. But it may turn out that a significant part of your users are actually using fairly cheap Android devices. And the result of that is the performance that they're experiencing is significantly different than the performance that you're experiencing for your website. So you might be testing your website on your phone and think to yourself, hey, this loads really great, it loads really quickly. But in reality, your users or visitors are experiencing something completely different. And this graph from Google actually highlights it. So this is a comparison of the performance of JavaScript on various devices. The same JavaScript code running on different types of mobile devices and just measuring how long the code took to run. And we can see that if we compare what was back in 2018, the latest iPhone 8, we can see that it was something like a factor of, what is it, 5 times faster or even 6 times faster than an average Android device. And if you look at the really low-end devices, we're already talking about a factor of 20, which means that the same JavaScript code on your new iPhone will run 20 times faster than that same code would run on a low-end Android device. Now, given that a lot of modern websites are really dependent on JavaScript to provide both this content and certainly for their functionality and interactivity, then having such slow running JavaScript will definitely impact the performance of your website and the experience that these people will have while visiting your website. And don't think that these low-end devices are just popular in third world countries. It turns out that low-end devices are actually very, very popular in the Western world as well, often outselling much more famous mobile devices like the iPhone. So a lot of people, for their, their salary isn't that good, especially at times like this. So they'll just go into Target or something and buy a fairly low-end mobile device, one that just does the work for them. The next point that I would like to mention is simply not measuring. If you don't measure, then you don't know. And some might say that ignorance is bliss, but that's certainly not the case with web performance. So if you haven't measured the performance of your website, then you literally have no idea what its performance actually is. It might be fast, it might be slow. Now, given that it's much easier to build a slow website than it is to build a fast website, if you haven't measured, then it's, probably just probability-wise, your website is probably slow, not fast. Okay then, so we've seen these reasons, and now I actually want to kind of get back to the title of this whole session, which is My Website is Slow, Now What? And I have to say that while I picked that title actually makes me upset because it kind of implies that you can build a website and after you finish building it, you can now think about its performance and see what you can fix. And that's not the correct approach. The correct approach is to actually think about performance when you start planning your website. So like I said, point number one was plan for performance. Performance needs to be part of your website's planning. It doesn't mean that you need to do each and every optimization up front, but it does mean that, for example, you need to specify performance the performance limits or the performance requirements that you want to achieve. And you need to take that into account during the development process of your website, and not finish the development process of your website and then say, oh, no, my website is slow and how can I fix it? Okay, having said all that, the main topics that we will discuss today can be placed into three categories. So the first category is how to measure performance. And as I just explained, it will be about how to measure the performance of your website as you're working on developing it. The next item that we will discuss is about performance budgets. It's mainly a method to prevent regressions in performance. That is, once you've managed to achieve the level of performance you want, how to prevent your performance from degrading as you add more capabilities and functionality and other stuff into your website. By the way, budgeting, as we will see, is also a good way to push performance forward, because it kind of enables you to improve without worrying about accidentally falling back. And finally, and the longest part of this presentation, will be about actually concrete actions that you can take to improve the performance of your website. So talking about measuring performance, there are actually three stages at which you can measure the performance of your website. First is actually during development, which is likely going to be on your local device or on some other device that you have immediate access to. So all modern web browsers these days have built-in development tools. Personally, I really like and prefer the Chrome dev tools, which are awesome, but that could be just because I'm really used to them. Edge, the new Edge, is effectively like Chrome, which means it essentially has more or less the same development tools, but you now have development tools in essentially every browser. And one of the great things about these development tools is that they actually have capabilities built in to measure and monitor the performance of your website as you're building it. So for example, in Chrome, you have the Audit tab, which will soon change its name to the Lighthouse tab, because it's actually internally using Google Lighthouse technology, which actually does a Lighthouse audit on your website. It can check for various things, but one of the things that it can check for is performance. So if you want a really quick analysis of the performance of your website, well, then just open DevTools, go to the Audit/Lighthouse tab, and then do an audit and see what you get. But there are many more sophisticated tools in there. There's the Network tab, which shows you how resources are downloaded and the impact that it has on the loading time of your application. And you've got the Profile tab that provides just a whole lot of information, sometimes even too much information, about what your application is actually doing and the impact on performance that each operation has. So that's about measuring performance during the development stage. Next is, at the other end of the spectrum, you can actually measure performance after you've deployed your application. In fact, you should probably do that, because that's the only way in which you can know what your real users are actually experiencing. And indeed, this is called real user measurements, or for short, RUM. There are many third-party tools that you can use for that. I'm not going to advertise any company, but just do a quick web search for web performance monitoring or for real user measurements, and you will find plenty of solutions out there, third-party solutions, that you can easily incorporate into your project. Alternatively, you can also build them you can build it yourself. There's the Web Performance API, which you can use, for example, to gather information about sessions. And then you can just send this information back to your server and collect them in a database. And then you can use tools like Grafana or Tableau to just graph this data. But if you don't want to invest too much effort into it, then definitely just go with a third-party solution. And then in between, you can use what is known as synthetic measurements. Synthetic measurements is about creating virtualized environments that simulate what you believe or expect real user situations to be like. So, for example, you can either like simulate a medium level Android device or even better, a low-end Android device, and then run your site through that and see what you get. And you can actually incorporate this into your build process, make it a part of your CI/CD process. And the great thing about that is that, for example, every time somebody pushes a commit, you can see what the performance implications of that will be automatically. And you can use this as a means to prevent accidental deployment to production of changes that significantly regress performance. And we will get to that in the next session when we talk about performance budgeting. When you're looking at measurements, there are a lot of tools out there. If you're talking about synthetic measurements, then one great tool for that is Google Lighthouse. Like I said, it's actually built into the Chrome DevTools, but it's also available as an online service. The screenshot here is what I saw when I ran the BBC website, news website through Google Lighthouse using a service known as Google PageSpeed Insights. Just Google for that and you will find it. It's essentially the exact same mechanism or engine inside. It's the same LiDAR process. It measures various aspects of your loading time, stuff like first contentful paint and time to interactive and so forth. And then based on the values that it measures, it creates a score. Actually, it creates two scores, one score for mobile devices and another score for desktop. Not surprisingly, usually the mobile score is much, much lower, especially because Google Lighthouse actually simulates a fairly low-end device on a mediocre network. They actually simulate a Moto G4 phone on a 3G network. Many of you probably have a better device and better network, but then again, potentially your users do not. Okay then, so we talked about measurements, but let's take measurements to the next level. And that next level is budgeting. By the way, here's a link. The presentation that I'm showing, we will share it with all of you later. So this link and other links that I will share will be available to you. This is a great post by Adi Osmani from Google about what is performance budgets and how to best utilize them. I'll do just a quick recap of that information, but if you want greater detail, I highly recommend reading that blog post, and you can also find YouTube videos dedicated to the subject of performance budgets. The basic idea behind performance budgets or performance budgeting is that you just set hard limits on a page, on pages that you create, which the development team are not allowed to exceed. So, for example, it could be quantity values like the download size. You might decide that your website should not download more than 170 kilobytes of JavaScript over the wire. That is gzipped and minified. And if for any reason that number is exceeded, that breaks the build. Now, obviously, this creates a challenge. What happens if you want to add additional functionality and that functionality causes you to cross a threshold? Well, then it's time to make some difficult decisions. You will need to think about, can I do anything else to reduce that size? Maybe I can remove old functionality that's no longer required. Or do I maybe even consider the value of the functionality that I'm adding? Is it worth having to make my limit higher? Is it worth raising my limit from 170 to, let's say, 220? Is it worth the users that I may now lose because the website will take longer to load for them, which will increase my bounce rate? Another potential milestone that you could specify is the loading time, like how long until some content becomes visible when the page loads on a certain device. Or you can just use tools like Google Lighthouse, which we saw before. You can specify that you don't want to exceed, the page should not exceed the Lighthouse score of 80 on desktop. And if it goes below 80, then it breaks the build. And it's actually, as we will see towards the end, it's actually it's actually fairly straightforward these days to incorporate, let's say, Lighthouse into your build process as a monitoring tool for the builds that you create of your site. Okay, then. So now we got to the actual meat of this presentation, which are the actions you can take to improve the performance of your website. And for that, what's important for me to say is that I'll be going through them fairly quickly. And the reason is that there are a whole lot of them. So any one of these bullets could likely be a topic for almost an entire talk of its own. And indeed, many of these topics, if you afterwards go and Google for them, you can find much more information about them. But what I wanted to provide you with is just a list of action items that you can, or check boxes that you can check off to make sure that you're doing everything that you can to improve the performance of your website. So one of the first things to do is to improve the delivery of the content from the server to your browser. I mean, after all, the whole point about web applications and websites is that much of them needs to be downloaded each and every time you visit that website, especially if it's dynamic content. And that means that the performance is obviously very dependent on how efficient you are at delivering that content from the server to the browser. So as I mentioned before, one of the key points is just to know your users and improve your server distribution. I already gave the example of having users in India, but a server in the States. Just moving your server to be at the same location where your users are located can make a really significant difference. And these days, with cloud providers providing data centers around the world, it's easier than ever. Another thing that you consider doing is using a CDN. The CDN is like a network of proxies which replicate your static content, so that instead of going all the way to your server in order to retrieve, let's say, a JavaScript file or a CSS file that are static and don't change, instead that file can be deployed to one of these proxies. CDN providers have their network spread out around the world, and content downloaded from a CDN is provided much more efficiently. By the way, we at Wix are in the process of moving as much of our content from being served just by our own servers to being served from CDNs. So obviously static content, like I mentioned, JavaScript files or CSS or images, but also HTML files. If they're not really dynamic, they themselves can be served from a CDN. And it's not just us. I mean, if you look at solutions like Netlify or Gatsby.js or Next.js and whatnot, all of them are about moving as much of the content to be served from CDNs in order to be delivered much more efficiently. Beware of redirects. I've seen many cases in which the same sites have multiple domains. And if you do that, then it's important that you actually put your site on your most popular domain and not, let's say, accidentally on your least popular one, because then whenever anybody goes to your site, they'll go to the server and that server will redirect them to the correct server, to the correct address. So that means just an extra round trip, maybe even more than one, just to be told where to go. And obviously, each and one of these redirects costs you loading time. These days, I considered HTTP2 to be a must. For those of you who don't know, HTTP2 is the newer or the latest version of the HTTP protocol. For years, we've been using HTTP 1.1. Now HTTP2 is out there. It's available essentially everywhere, and you should definitely be using it. The reasons, it's much better at delivering lots of content thanks to a feature called multiplexing. It also does compression of the HTTP headers. In general, it's just a better and more efficient protocol than the previous versions of HTTP. And as a bonus, there's the Quick protocol. Quick is a kind of a replacement for TCP, which is the layer that HTTP is built on top of. Now, TCP is awesome. The internet was built on TCP, but TCP is getting kind of old. It was designed back when the web was, or the internet was a different kind of place, and connectivity was different. And these days, TCP actually can throttle your connection at the beginning of your session until it determines how much bandwidth you actually have. Quick is just better at that, and it's probably going to be part of the upcoming HTTP 3 standard, but you can already start enjoying it with some providers. Make sure to have proper caching headers on all your content. The most efficient delivery of content is when the content doesn't need to be downloaded at all, because it's already cached on the endpoint device or on a proxy in the way. And ensuring proper cache headers can go a long way to making sure that your website is as efficient as it should be. And I can't tell you how many times I've seen high volume websites neglect to set proper cache headers on all their content. Luckily, tools like Google Lighthouse will actually flag this sort of thing for you and highlight content that's not properly cached. Use that, look at their suggestions, and fix the cache headers. Another important thing is to try to download stuff in parallel as much as you possibly can. So don't make a content A dependent on content B, so that until content B finishes downloading, content A doesn't even start. Try to download as much of your stuff as possible in parallel, be it JavaScript or CSS or images or whatnot. So for example, if your JavaScript is required to set the SRC attributes on your images, it means that your images won't start downloading until your JavaScript actually downloads, and then you've lost that parallel download. Compression these days is supported by all browsers that are out there. You're unlikely to encounter a browser that doesn't support compression, and therefore not using compression is a real shame. Compressing content can improve its download time significantly. For JavaScript, for example, compressing content can reduce its size by 50%, 60%, even 80%. gzip is the most common compression protocol out there. The newer Brotli protocol is also starting to gain a foothold. It provides even better compression, but it's beyond the scope of this presentation to discuss it. And also remember to minify HTML, CSS, and especially JavaScript. Again, it will reduce the download size and can also potentially improve the parsing time. These days, media, that's images and videos, constitute a very significant portion of the download size of a website. Excuse me while I close the window here. Noise coming from outside, the problem of doing a presentation from home. So anything we can do to improve the delivery of content, of media, will improve the overall loading of the size. So use tools like the Chrome DevTools Network tab to check for extra large downloads and see what you can do about these, if you can optimize them in any way. For example, you should definitely prefer JPEGs to PNGs. PNGs are required when you have like invisible backgrounds, but if you don't have those, then in most cases using a JPEG format rather than a PNG will reduce the delivery size dramatically without noticeably impacting the quality of the image. I mean, if you're a brain surgeon, then you might want to use PNG, but otherwise JPEGs suffice like 90-something% of the time. And they're often like a tenth of the size. Convert JPEGs and PNGs to WebP. That will improve the delivery, reduce the download size by 50, 60, sometimes even 80%. WebP, for those of you who don't know, is a newer image protocol created by Google. It's supported almost everywhere with the exception more or less of Safari. Hopefully Safari will support it eventually as well. Maybe they've already started to, but we will talk about how to fall back to JPEGs and PNGs when WebP is not supported, but in most cases it will be, so converting to that protocol is certainly beneficial. SVGs, when you can use them for stuff like logos and icons, are significantly smaller than JPEGs and PNGs, and also are sharp from the get-go, and regardless of how much you zoom the screen. So if you can use an SVG, you generally want to use it. Avoid GIFs images. A lot of people still use GIFs for animation. I once saw a website with an animated GIF, a spinning necklace, because they were selling jewelry, and just that spinning necklace, a relatively small GIF, weighed 5 times as much as all of the rest of the page put together. So just don't use GIFs. Instead, if you want to have a short animated clip, use a looping video instead. The picture element, or the picture tag, is a great way to leverage a lot of these capabilities. It makes it possible to download right-sized images. By that I mean that you can load really big images for the desktop where they have to cover a lot of real estate, but much smaller in terms of width and height images for mobile devices. The picture, and you can do that using just a simple HTML tag instead of having to use a lot of sophisticated JavaScript. The picture tag is awesome, and it's supported by essentially all browsers for the last 3 to 4 years. If you're using an image for a background, and often backgrounds are fairly large, then you can think about reducing its quality. If you're using a JPEG image format or a WebP generated from a JPEG, you can actually specify the image quality, and specifying a lower quality can reduce the download size significantly. So you probably don't want to do that for a foreground image, but for a background image that's just there to create a certain ambience, that's certainly something that's doable. The last thing I want to mention for images is lazy loading. This is a relatively new extension that Chrome introduced, but now supported by other browsers as well, Firefox and New Edge, etc. And those browsers that don't support it, well, it doesn't do any harm. Basically what it says is that if the image is down the page, not initially visible, then the image won't be downloaded until that the visitor actually begins scrolling down the site, the page. And that means that you download only the stuff that you actually need to see, and not stuff that can be downloaded later when you actually scroll to it. That can also significantly reduce the total initial download size. Turns out that you can also optimize how you use text. For example, make sure to just include some text. I've seen websites, especially on mobile devices, that literally have nothing above in the initially visible area, what I call above the fold, except images or maybe a gallery before the user actually starts scrolling down. And that means that, for example, if there's an image, until that image finishes downloading, there's no content for the visitor to see. And, obviously, text loads much faster than images because it's just a part of the HTML. Putting text is not enough. You also need to ensure that you have good contrast, because if it's difficult for me to actually read the text, it does me very little good. And it hurts my perceived performance of your page, because it takes me longer to identify the text to successfully read it. Animations are really cool. They draw attention to important stuff. But remember that until an animated text finishes animating, you can't actually read it. So if you've added a 2-second animation to your title text, it means that you've effectively introduced a 2-second delay until that text becomes readable. And so I'm not saying avoid animations, but I am saying that at least some of your content, I think, should not be animated. Avoid text and images, slow to load, and also really bad for SEO. It's become really popular to use custom fonts or downloaded fonts for text, but just remember that web fonts, that if you're using custom fonts, then until the font finishes downloading, the text may not be visible. So just limit the number of custom fonts and font weights that you use. I've seen pages that download 10, 20 custom fonts, and as a result really hurt the time until the text becomes visible. And specify built-in fallbacks for those custom fonts. So if while they download, maybe it will be displayed using maybe not the font you want, but at least it will be readable. And you can use the font display CSS descriptor to control what happens, whether to use the fallback font while still downloading the web font. JavaScript is a big chunk of our content these days and has really bad implications for website performance. So just don't use JavaScript for stuff that you can do with HTML and CSS. For example, instead of using JavaScript to lay out your page, use, let's say, the new CSS grid capabilities. Or like I said, the picture element instead of implementing it using JavaScript. Avoid render blocking downloads. That means using the async or defer attributes wherever you can, or at the very least, put your script tags at the bottom of your HTML. I prefer using the async tag wherever possible. Use a bundle analyzer to optimize the packages. I've seen huge packages that include multiple libraries, multiple instances of the same library over and over again, like 3 different versions of Lodash within the same bundle. So a tool like the Webpack Bundle Analyzer is a great tool to analyze and find and remove unneeded libraries. Use tree shaking to eliminate unused code. Basically, it means that if you're using Lodash but only one function out of Lodash, instead of bundling the entire Lodash library, you just bundle that function that you need. Likewise, code splitting reduces size by breaking the bundle down into smaller parts and then downloading the parts on demand only when they're actually needed. Sometimes it actually makes sense to bundle small packages together into bigger bundles because then you get the benefits of better compression. Larger files compress better than lots of small files. On the other hand, breaking up bundles has also benefits because when stuff changes, you don't need to download the entire bundle all over again, and it's more efficient for parsing. So all in all, bundles of approximately 30 to 50 kilobytes, that's where you want to be. Certainly, if your bundles are bigger than 100 kilobytes over the wire, you want to start breaking them apart. Some more stuff that you can do, but with a bit more effort, is implement server-side rendering instead of doing everything on the client side. Use progressive image download, which means that you first show a low-res image and then replace it over time with a higher-res image, which is obviously larger and a longer download. I already mentioned lazy loading for images, but you can apply the same thing for iframes and for other resources as well. Use resource hints like preload and prefetch. That means that you can delay the actual download and processing of the content. You can delay the processing of the content until you actually need it. But if the browser has available bandwidth, you can actually start downloading it sooner. So when it's actually needed, it's already available and you don't have to then wait for the content to download. And again, taking everything to the next level is to actually implement a progressive web app with a service worker. It really controls when content is downloaded much more so than just simple cache headers. And there's even more stuff that you can do. Stuff like if you're doing Ajax query to backend database, then you probably want to optimize your database queries. Make sure you're using the correct indexes. You should actually measure how long your queries take to execute. And we talked about knowing your users. If you know that all of your users are using modern browsers, then why are you still supporting, let's say, IE8? Maybe you can drop support for IE8, give them better performance and greater functionality. And if you know that you don't need to support older browsers, then you can avoid using all sorts of polyfills and libraries and transpilation that's required for those old browsers. Use code coverage tools like the ones available in the Chrome DevTools to analyze and find maybe some of the JavaScript or CSS that you're downloading isn't even needed. Use a profiler to optimize your JavaScript. And just, make changes, do experiments, measure the results, keep what works, and throw away what doesn't. To conclude, I want to say, again, going back to the very beginning of this presentation, that an ounce of prevention is worth a pound of cure. So have all these processes in place, make all the plans that you need in advance. That way you won't get to the point where you've built your website, it's already deployed, and then you find out that it's too slow. Here are some links. I won't go over them. Like I said, I'll be sharing this presentation with you. These are useful links for tools and more content to read about some of the topics that we've discussed. So thank you all for joining us, and have a great day.